Howdy, my name is Mari Wilcock and I'm a part of the FRESH REEU program at Texas A&M University. I'm going to be talking a bit about my research project, evaluating pecan waste pyrolysis byproducts and effects of atmospheric cold plasma, or ACP, on produced bio-oil. Welcome to the Beta Lab. Here we have lab space and machinery, such as a bomb calorimeter, elemental analyzer, and 2 pyrolyzers. So my project in the lab and in the FRESH REEU program is to take samples of pecan middle septum, which is called pecan waste in this research, and pyrolyze it at 3 different temperatures, 400 degrees Celsius, 500 degrees Celsius, and 600 degrees Celsius. We're going to take the biochar and the bio-oil produced, assess its properties, and then pick one of the temperatures to run cold plasma treatment on. This is the pecan middle septum. First, pecans are ground in the hammer mill so we can pyrolyze it. Next, we run proximate analysis on the samples, finding the moisture content, volatile combustible matter, fixed carbon, and ash. Next, the fun bit. We put about 300 grams of ground pecans in the pyrolyzer for 3 to 5 hours. This gives us the products of liquid bio-oil, solid biochar, and synthetic gas, or syngas for short. We found that the pecan waste produced a significant amount of biochar, ranging from 43 to 56%. In order to calculate the energy balance, we used the bomb calorimeter to find the heating values of the products, which we found increased as the temperature at which we pyrolyzed the sample increased. We also ran char and oil samples through the elemental analyzer, finding out there was very little carbon content. Now, we're treating a sample of bio-oil with cold plasma. Since pecans treated at 600 degrees Celsius produced the most oil, that oil was used. Since there is a very large amount of the aqueous portion of the oil rather than the darker organic portion, I filtered and used that to be treated with cold plasma. 15 milliliters of oil were placed in Ziploc bags, which were filled with an inert gas mixture and heat sealed. This is our atmospheric cold plasma machine. So as you can see, I have 3 samples of bio-oil here ready to go. So what we're going to do is we're trying to see if cold plasma will be able to change the oils into something more suitable for commercial use and for normal everyday fuel. I'm treating this sample of oil at 70,000 volts for 10 minutes. After it's done, it'll sit in the fridge overnight. So here we go, we got our first sample. You can better see the cold plasma do its work in the dark. There! Now that we have treated and untreated samples of oil, we're going to further analyze them by using FTIR spectroscopy and GCMS testing. So here, I'm filling the vials that we use for GCMS with the treated and untreated oil, and it'll run overnight. The FTIR testing was done earlier in the day, and so far we noticed that the treated and untreated oil was actually really similar in composition. We'll see what GCMS has in store for us tomorrow. I hope you enjoyed some more info on pecan pyrolysis and cold plasma treatment. Thanks and gig 'em!